Sliding window is one of the most fun patterns to solve. That is because you can actually take up a data structure like an array and then you can define a window over it. This window now has some elements and now you can slide this window throughout your entire array. I feel that this kind of keeps you focused on the goal and it really becomes interesting as well. Let us find out more about it. Hello friends, welcome back to my channel. I feel that the name sliding window is intuitive in itself. You have a window that contains some elements and then you are sliding this window. To understand it better, let us immediately dive into some problems. That will give you a very good idea what this pattern is all about. You might have already seen problems of this pattern. You need to find the maximum sum of a sub-array of size k. You are given an array that isn't sorted and you are given a value k. It means you need to find me a sub-array of size k, that means 4 elements, such that you have the maximum sum. So what is the brute force approach? You will try to find out all of the sub-array of size 4 and then you will try to keep a track of all of the sums. But over here, what you can do is, you know that you have to look at 4 elements at once and they all should be contiguous. This means you can apply the sliding window over here. Technically, what is going to happen is you are trying to define a window that contains 4 elements. And if you look at these 4 elements, you find that the total sum of these elements is 3, correct? Now, you have to traverse other elements as well. For a brute force approach, you will try to find out the other 4 elements. But with a sliding window, what you can do is you can simply take this window and slide one step ahead. Once you slide it, what did you do? You added 3, so you do a plus 3, and then you removed a minus 2. So you remove minus 2. Now you will get your new sum, and that is 8. So this is how we are taking advantage of a window that is sliding. In the next step, what is going to happen? You will slide your window one step ahead again. So what did we do? We added an 8 and we removed a minus 5. So now what do I get? I get the sum as 21. This is what we are doing over here. We take this window and we slide it one step at a time all throughout the array. And that is why we call it a sliding window pattern. You know that this size is gonna remain fixed. Or rather, you are talking about elements that appear contiguous. That is your very big indication. So now you know what to do, right? You can keep on sliding this window at every set of 4 elements and just keep a track of the sum of each of these 4 elements. Even this is easy. You just add the new element and remove the previous element. That's it. Just keep a track of all of these sums and in the end, you can return the maximum sum that you found. If you want to return that array, you can keep a track of these 4 elements also. And that's it. You have found out the answer. You might have seen other problems like this also. For example, in this one, you have to find out the average instead of the sum. Do you really think it requires a whole different implementation? It is literally the same logic. You take up your window and then find out the average. And then once you slide it, just add the new element, remove the previous one and get a new average. Keep a track of the average across your entire window and once you reach the end, you can stop. That's it. You solved one more problem. And sliding window is not just limited to integers. For example, in this problem, I need to find out the maximum vowels in a substring of size k. Once again, all of these words are just tweaked and asked in a different manner. What do you have to do in this problem in the end? Once again, you are given a certain size. You know that you will have a substring of this particular length of the size 4. It means I will have a window of size 4. And once again, what do you need to do? Just count how many vowels can you find. For example, in this particular window, you can only find one vowel. When you slide ahead, this time you have 2 vowels. Again you slide ahead, again 2 vowels. Again you slide ahead, again 2 vowels. So you just keep on scanning your entire array like this. And at the very end, you can simply return, okay, this is the maximum number of vowels that I found. All I'm trying to say is there are multiple ways to ask the same question, whereas the underlying idea about applying a sliding window will remain the same. So what did we learn so far? We understood how a sliding window actually works and what is the intuition behind it. You are looking at some contiguous elements and then you are sliding this window all throughout your input array. Now, there can be two different types of sliding windows. The problems that we just saw, they were a fixed size of sliding window. So whenever you hear terms like do something with k elements, that means you are restricting that, okay, I need to look at only these k elements. In those patterns, you will take up this window and then you are gonna slide it one character at a time. When you slide one character at a time or even faster, it simply means that you are iterating over your entire array. You are able to perform a complete scan, and that ensures that you have covered every element. Now, this is the most basic part how you use a sliding window pattern. There is, however, one more way in which sliding window patterns are generally used, and that is where things start to get a little tricky. It means the length of your sliding window can change. We call this as a variable size sliding window pattern. The idea over here is very simple. Let us say you're starting off your window just with one element. Now, based upon your problem statement, what you may want to do is you may want to cover more and more elements in your array until a certain condition is met. So you might have encountered questions like, okay, find me the array that has k distinct characters. It means you are looking for some particular k characters. Now, it could be possible that all the characters are repeated, so you are continuing to increase the length of your sliding window until you find those distinct characters. Or you could even use hash sets or even some kind of a frequency map to keep a track of those k elements. So whenever you are hearing terms like at most k characters, it means you need the concept of a variable sized sliding window. For example, you covered certain elements, but now when you want to cover your entire array, sometimes you may have to remove some elements from your window. So what you will do is you will start reducing the length, and it could be possible that you may want to include more characters. All of this happens dynamically as per your requirements. It could be possible that after several iterations, you have now covered your entire array. All of this isn't very complex. Let us look at some problems that will make this concept even more clear to you. For example, look at this particular problem. You need to find me the longest substring without any repeating character. I have this entire string with me, and you need to give me a substring in which none of the characters are repeated, but the length should be maximum. So you can find several of these strings, right? In all these strings, none of the characters are repeated. But if you take this particular string, this I now gets repeated. So this is where you stop. For a brute force approach, you will try to now start with H, then you will try to start with I, and so on. The time complexity is gonna get worse and worse. How does the sliding window help over here? You start with the first element. You see, okay, currently no character is repeating here. Then you include one more character. Once again, no character is repeated. What you can also do is you can keep these characters in some kind of a hash set, so you can easily find out if a character got repeated or not. You will continue ahead. You see I is also not present. You see S is also not present. And now you see an I again. What happens? This I is repeated, so you will not include it in your window, but you found a checkpoint. You found that, okay, I can find one string of the length 4 which doesn't have any repeated characters. So this is one benchmark. When you have to go ahead, what will you do? You will now try to add a character. I got added, but since it is duplicated, you will want to keep on removing characters until your sliding window has unique characters again. So I will keep on removing until I don't have any duplicates. I still have two eyes. I remove this. I still have two eyes. I remove this. And now I only have one eye. All the elements are again unique. But this time the length is 2. Since 2 is less than 4, so I can ignore it. You will try to repeat the same process again. You add an S. So now you have repeated characters. So you will reduce the length of your window. You will go ahead now. You find A. None of them are repeated. L. None of them are repeated. O. None of them are repeated. N. None of them are repeated. Then G and then a X. What did we do? We covered the entire string and none of the characters are repeated. So what did we find out? We find out that the longest substring without any repeated characters is actually 8. And we were using the concept of a variable size sliding window. The window was sliding, but its length was not fixed. And that is your answer. But these problems can start to become more and more generalized and they might feel a little bit more tricky. But you don't have to worry about it. Just focus on your basics and everything will be fine. For example, look at this next problem. You have to find out the longest substring with at most k distinct characters. So the underlying idea will still remain the same. You will want to have a variable size sliding window. But just looking at repeated characters isn't enough. You will also want to make sure that the string that you're forming, this string should have at most k distinct characters. For example, in the previous question, as soon as I got an I, then I had to start it to reduce the length. But over here, I am good with at most k distinct characters. So if I try to add one more element, how many distinct characters do I have? I still have only 4 distinct characters. So this window works perfectly for me. Can I go ahead? Yes, I can. Because even now, I only have 4 distinct characters. But can I go ahead now? As soon as I include an A, I now have 5 distinct characters. So this is an indication that you need to start reducing your length. So what will you do? You will try to cut off one element. Now again, you have 4 elements. So that works wonderfully. Now go ahead. Once again, you have 5 distinct characters. So you will need to reduce your length. Similarly, you will keep on going ahead. You include an O. Now again, you have 5 characters. So remove this. Notice that if you removed an I, you still have 5 distinct characters. So you need to reduce the length even more. When you removed an S, you still have 5 distinct characters. So you need to remove more characters. And that happened because these characters were duplicated, correct? So that is the idea. Now, once again, you have 4 distinct characters. So this also becomes a candidate. Similarly, you will keep on scanning your entire string and that will cover every element. But you have already found out that the longest string with at most 4 distinct characters is this particular substring. You might have guessed it. The problem statement is actually the same. You are just playing around with all of the different conditions that could be asked. So basically, how do you identify that when you're given a problem, can you apply the sliding window pattern or not? There are certain cues that you can watch out for. For example, the first thing that you need to look at is a linear structure. Sliding window only operates when your structure is linear. You cannot use it on trees or graphs. So arrays and strings are perfect examples because all of these elements are contiguous and then you can have a window on top of it. That means you are looking at only certain set of elements. And that is why a contiguous segment is very, very important. Because notice what we demanded in all of our problems. We were looking at sub-arrays, substrings, a part of the string, a part of an array. Those are your major hints. And notice what the problem asks you for. Find the minimum and the maximum. That means you are looking at a window and you have to tell me, okay, this is the maximum size or this is the minimum size. Count distinct or duplicates. You are maintaining a hash set to find distinct elements. You are also maintaining a hash set to find duplicates. You could also maintain frequency maps that is giving you a state of what is happening in your window. Basically, this window is your area of concern. You are trying to derive all of the results that you can find from this window. Let us now look at one fancy problem. You might have all seen the problem fruits into basket. Basically, you are given an array that is certainly a garden and all of the fruits are in a line. You are given a basket and this basket can hold only 2 types of fruits. You have to make sure that whichever two type of fruits you pick, you need to have the maximum quantity of it. And all of these fruits are contiguous. So what do you see over here? Isn't this problem literally the same as finding the longest substring with at most k distinct characters? What do? You start picking up fruits. You pick up an apple and then you pick up an orange. You found two type of fruits. That's it. And that's good. So you record it. Now you try to pick a watermelon. You cannot have three types. So you will want to reduce your window. This is perfect. Now try to add more fruits. Can you add a watermelon? Yes. So now you are able to add three fruits. So that is a bigger number. Works perfectly. Try to add the next fruit. Can I add a banana? No, because now I will have three type of fruits. So remove the orange. And this is good for us. I still have three fruits, so I don't need to update it. Try to add the next fruit. Can I add an orange? No, because now I will have three different kind of fruits. It means I will need to reduce my size. Reducing the size by 1 does not help. I still have three different fruits. Remove one more fruit. I again have only two type of fruits, so that is good. I can now increase. Can I add one more orange? Yes. Can I add an apple? No. So I will reduce it. Notice that I was still able to have only three maximum fruits. Can I add an orange again? Yes, because once again in my basket, I only have two type of fruits. But the total fruits I collected over here is 4. 4 is greater than 3, so I will reject this value. I have scanned my entire array. That means 4 is my answer. So do you see how sliding window is helping us? It helps to scan the entire array. It removes the order of n square complexity. It helps you to focus only on a certain state of elements and you are maintaining that state. Up till now, we have been looking at the maximum substring, the maximum number of fruits. Similarly, you can also have a problem where you have to find the minimum size of a sub-array with a particular sum. You are given this array and you have to find the target of 7 as the sum. So what do? Again, a variable size sliding window. You take up the first element. The sum is 2. It is less than 7, so you don't have to worry. You do 2 plus 3. It is still 5. So it is still smaller. I add one more element. The sum is 6. Still less than 7. And now I add one more element. The total sum now becomes 8. And what is the length of this array? The length is 4. So at least I found out one possible solution. But until I scan my entire array, then I am not sure. So what are you basically doing over here? This is the left pointer and this is the right pointer. To increase your length, you do a right plus plus, and to decrease your length, you do a left minus minus. So what I will do over here, I will do a left minus minus. What is my sum now? My sum is 6. It is less than 7. So I will need to increase my right pointer to increase the sum. So when I'm increasing the size of my window, my sum increases. When I'm decreasing the size of the window, the sum decreases. I add the next element and now the sum becomes 10. 10 is greater than 7. So this is a possible solution. But I can also now start to reduce my size. I see 4 plus 2, 6 plus 1, 7. So I found an even smaller size. That is 3. Can I reduce it further? No, because now the sum becomes 6. I try to add one more element. The sum now becomes 9. So I found one more answer. But I can also try to reduce it. So when I reduce it, my sum is still 7. So I found an even smaller solution. So I will update this value to 2. I have scanned my entire array. That means 2 is my answer. So a sliding window is also helpful when you have to find the minimum of something. The next problem is also very, very interesting. Maximum consecutive ones. You are given a binary array, that means just zeros and ones, and you are given a value k. What you can do is you can pick up at most 2 zeros to convert it to 1. And these zeros could be anywhere in the array. And then you have to tell me what is the longest length of all ones that you can find out. So what do you do over here? Once again, a variable size sliding window. You have to find out the ones, correct? So start your window. Currently, you haven't flipped any of the zeros. That's good. Now increase the length. This is good. Increase the length. That is good. Now increase the length. What do I have? I have a 0. I haven't used any of this. So what I'm just going to do is, I will change this k to 1. And notice my left pointer is here, my right pointer is here. I will try to increase the length more because I am still allowed to flip one more 0. My right pointer comes here and this value now changes to 0. It means I cannot flip any more zeros. So what happens if I try to go ahead now? If I try to go ahead, I cannot flip this 0. So I actually need to stop over here. And this gives me one particular length. I now know that I can have at least 5 consecutive ones. This fact is known. I still have to scan my entire array. Notice that I couldn't have included this array. Why? Because the value of k is 0. So I will start reducing my length. I reduce this, but this was not a 0. So the value of k still remains a 0. I remove one more 1, no change. I remove one more 1, no change. I remove this 0. Since I removed a 0, this value of k now changes to 1. It means I can include one more 0. As soon as I include a 0, the value of k now changes to 0 again. It means I cannot include more zeros. But I still want to keep on going ahead. That is only I will know if I have more zeros or ones. I see a 1, that is fine. So you keep on going ahead until you see a 1. So what do we have now? We have another window of a greater size. This window is of the size 6. So I can update it and I can store 6 is my longest length up till now. Can I include the next 0? No. So I need to move my left pointer one step ahead. This pointer moves ahead, the size of the window reduces, and now I am able to ingest one more 0. The length, however, still remains 6. I have completed the scan of my entire array. I found out that, okay, 6 is the maximum length of maximum consecutive ones. All of these examples give you a good summary about the components involved in a variable size sliding window. The idea is very, very simple. If you want to expand your window, then you take up your 2 pointers and then you do a right plus plus. So I have my 2 pointers over here. Doing a right plus plus will increase the size of my window. And I have included more elements. Based upon your conditions, you might want to shrink your window also. So you do left plus plus. You had your window like this. You have a left pointer and a right pointer. When you do left plus plus, your window size becomes smaller. Basically, you are trying to maintain the state. You are trying to maintain the particular condition that is being asked in your problem statement. So you are trying to validate, is your window valid or not? And based upon that, you are increasing the length of your window or reducing the length. To maintain this state, you can use a hash set, a running sum, a frequency map, or min and max queues. And while you're doing all of this, you need to make sure that you reach the very end of your array. It means you have completed the entire scan. And while doing all of that, you might want to update a counter, you might want to keep some kind of a track. It just means that you are trying to update the end result that will eventually solve the problem for you. So what did we learn over here? You need to somehow look at the problem and identify the sliding window opportunity. For example, whenever you are being talked about a contiguous subarray or a longest or a shortest segment, it means that you want to look at different sizes. It simply means you are looking at a variable size sliding window. When you're being talked about the maximum sum or a minimum value between certain k elements, it means you're looking at a fixed size sliding window. If you're looking at most k elements, then you want the minimum possible sum. You want the minimum possible elements. It means a shrinking window strategy, meaning you will try to include more and more elements and then try to shrink it as per your requirement, as per the condition that you want to meet. And likewise, we also discussed the other two cases. If you are looking at unique elements, that means you might want to use a hash set or a hash map. And looking at moving averages or rolling sums, those are once again fixed window where you are updating your result. I hope all of these problems now give you a very good idea how the sliding window pattern actually looks and in what scenarios can you apply it. Tell me in the comment section below what other problems have you seen. Or what other complex cases that you have observed where a sliding window pattern is very, very helpful. I will be really happy to discuss all of them, and it will also become a very good collection whenever you want to review this particular concept. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This really keeps me motivated and I can make more such videos. Also remember, you can now schedule one-to-one sessions with me to solve any sort of doubts. And also a huge shout out to all of the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments and early access to new videos as well. Stay tuned for my upcoming video. Until then, see ya.